Hello, today I'm here to explain the polar and rectangular representations of a sine wave. Now, as you can see, these conversions are usually meant to change the sine wave from the form shown here in the graph to one of these more useful equations. A common way to start either of those conversions is to begin with a general form of the sine wave, a sine wt plus theta. We can actually ignore w here, since it is usually found by multiplying pi and frequency, and we ignore frequency for these conversions, meaning we can ignore w while we're converting. Now, for our example, let's say a is 70, theta is 30, which would give us 70 sine t plus 30. Now, theta for both the general purpose of form and the polar form are actually the same, meaning that we already have theta for the polar form. Since polar form is now easier to find, all we have to do is find z, which is equivalent to A, or the peak voltage, divided by a square root of 2. The reason for this is because Z is actually representative of the RMS voltage, or the effective voltage, which is the peak voltage, which is the voltage found here at the top of the sine wave, divided by the square root of 2. That makes Z, in our case, 70 divided by the square root of 2, which in a calculator should come out to 49.5, which gives 49.5 and 30 degrees as the completed polar form. From here it's easy to find the rectangular form, as both these axes, j the imaginary axes and a the real axes, all of their vectors actually add up to make z. So with some simple trigonometry we can find both a and b in the rectangular form. A is equivalent to z cos, and then the angle, which as we can see here is equivalent to 30 degrees, and b is a similar equation except with sine instead of cos. And punching that in the calculator should come out to 42.9 for A and 24.8 for B, which leaves 42.9 plus 24.8J as the completed rectangular form. And that's all. Thanks for watching, hope it helped.